This lab, which is determining the molarity of vinegar using microscale techniques, involves the reaction of vinegar, which is a dilute solution of acetic acid, with a known concentration of sodium hydroxide. In the reaction I'm going to do, I'm going to use 0.50 molar sodium hydroxide, and I'm going to titrate that against a known number of drops of the acetic acid or vinegar. And I'm going to titrate this to a phenolphthalein endpoint. So the solution should go from colorless to pink at the endpoint. The reaction probably could be done about 3 different times in the span of less than a class period. Now, I'm going to put this pipette stand in a position where I can add the drops of first vinegar, and the reason for the pipette stand is that we found that the drops are most uniform in size if the pipette is held vertically. So that's why I want to do that. And students, if they don't have a stand, need to be reminded, or even if they do have a stand, be reminded that drop sizes are most uniform when you hold the pipette vertically. So I'm going to add 25 drops of the vinegar to each of 3 well holes. In this video, I'm just going to do 1 well hole and titrate there, but I would do the same with the other 2 well holes, doing things in triplicate. The first of the titrations I would do very quickly, and then the second and the third much more carefully, so that I would know when I'm nearing the end point and get to the end point where there's only requiring only a couple of drops of additional sodium hydroxide to get to a phenolphthalein endpoint. I've added the 25 drops of the vinegar. I'm going to remove the pipette. When you remove it, do not squeeze the bulb, because more of the vinegar will come out. The phenolphthalein is a water alcohol solution and comes out very quickly. So when I add that, I'm only going to hold the pipette at just slightly below the horizontal, and add 1 or 2 drops of phenolphthalein. Now I'm going to titrate with the sodium hydroxide to a phenolphthalein endpoint. I can slide the pipette down so that it's near the well hole, avoiding less spattering. And to stir, I have a plastic stirrer which I created by cutting the tip off of a straight stem pipette. So now I'm going to add by counting drops. Now you can see the color of the indicator as I'm adding the sodium hydroxide, but that color doesn't linger very long. You notice as I'm stirring, the color of the phenolphthalein indicator does go from pink back to colorless. There is a slightly cloudy appearance, and that's due to the fact that phenolphthalein is not very soluble in water. And as I add more of an aqueous solution, the phenolphthalein becomes less soluble. Notice the pink color staying, but when I stir, that pink color goes away. And as the pink color lingers, I know that I'm getting very, very close to the end point. and it looks as if I've reached my end point, as stirring the color remains. Now all that's left, the calculations. To clean the well holes, I'll take this over to a sink. In my classroom, I refer to it as a side sink. And I will have the water running, shake the solutions into running water, and then rinse the well holes several times with distilled water. And then just shake the excess water into the sink and bring the micro well plate back to the setting where the reaction took place. Although this isn't the kind of straw that I use to make a pipette holder, I will demonstrate how to do it. You want to take your scissors and cut part way. And then might want to make this a bit longer. And then what you do is you take this and fold it onto itself, and what you have is a little loop. And you can put another straw in there. And I would take a hole punch and punch a hole somewhere over here, flatten this out. Use a hole punch to punch a hole in it. Make sure that the tubing is wider than the diameter of the hole. And then what you'd have is the second straw, and the second straw would go right through that hole and support it, similar to a ring stand. And this straw would then sit in the well hole just like that. So you'd have your support and you'd have your pipette holder just like that. And that's how you make a very inexpensive pipette holder that would work to support a pipette vertically.